Welcome. This is the first video in a sequence on the Introduction to Statistics. The first section that we're going to cover is from your book's 14.1, and it's about enumeration. And in this video, we're just going to discuss an example study to get a feel for the whole process of statistics. In the future videos, we'll talk about sampling and the differences between observational studies and experiments. But to start out, we're just going to go with an example. So, the research always starts with a question. And in this case, our question is going to be, does inoculation reduce the risk of death due to smallpox? And we'll critique the question itself and at the end of the video here. But let's just give ourselves the setup here. In Boston in 1721, there was an outbreak of smallpox. So researchers at the time followed a little over 6,000 citizens who fell into two groups. Some had been inoculated and some had not been inoculated prior to the outbreak. And to be clear about what inoculation is at the time, they would take the scabs of people who had smallpox and dried them and ground them up into a powder. And then the process of inoculation was taking these smallpox scabs and rubbing them into wounds of people who had not been infected with smallpox. So, this was definitely a question that people would want to know, because if somebody comes to your door and asks, do you want scabs rubbed in an open wound, your first response should be no. But if there's some data that says that might actually protect you, maybe you'd go with the scabs. So, with that in mind, let's move on to what the data would look like that the researchers would collect. And you might think that there should be more than this, and there probably was, but a good thing to think about is what's the simplest amount of data you could ever collect in order to answer a question, because it's a good starting place. So the researchers could collect their information in just 3 columns. The patient, and maybe they would have a name instead of the number, but it's fine if we just numbered all the patients. And then whether or not that individual was inoculated or not, and whether the individual lived or died. And with just that amount of information, we can make a simplistic conclusion about our research question. So, the next step here is going to be to organize the data. And it's important to maybe look back at this table and see the dots. And if we had the full table, it would take up a lot of lines of paper. I mean, there's supposed to be 6,224 people here. And the point of organizing the information is to make it more readable in a sense. I mean, all the information is here in this list if it were really filled out. But you can't draw your conclusion from that. It's too much to process. So we attempt to simplify it by summarizing it in some fashion. And this table does one level of summarization. And we count up how many people have fallen to which groups. So these numbers on the inside, let's just look at this one in particular. We want to be able to interpret. So this 238 people, there are 238 people in this list. That both were inoculated and lived. Were inoculated and lived. So for instance, here's one of those people. That's different than say these 5,136 who lived but were not inoculated. So here's one of them. And so if you just count up however many fit that description, and then you just kind of tally them up and put them into this table. So in the column to the far right and in the row in the bottom, we see these total this label total. And the way that we should fill out the empty blocks in the table is by adding across and adding down. So the total here is referring to the total number of people who lived and the total number of people who have died. And if you lived, you were either inoculated or not. And so if we add these two numbers together, we'll get the total number of people who lived. So we can do that. 238 plus 536 is something that we just don't want to make an arithmetic error on. So we'll just retreat to our calculator. It's 5,374. We can add 6 and 844 to get 850. And read off that 850 people died in this study. 6 of them were inoculated, and 844 were not. And just to check, 5,374 plus 850 equals the 6,224. This is good that these two numbers add up to 6,224 because everybody either lived or died, but nobody did both. So if you count out the total number of people who lived and add that to the total number of people who died, you should get the total number of people who were in your study, which was in fact 6,224. Adding vertically, we have 244 and whatever those are, 5,136 and 844 for 5,980. We can read off that 5,980 people were not inoculated. So the vast majority of people did not receive the treatment. Let's move that aside for a second, scroll down, see where we're at. So we have the data organized. Maybe one thing to note is by producing the summary that's in this table, we no longer have the information about who was inoculated and who was not inoculated. So by summarizing, we kind of lost some of the details of the table above. But this is still more useful information than the giant list of what happened to the individuals, even though, so it's one step removed from the source data. The next thing we want to do is analyze. And in the case of this study, we want to analyze, we want to compare numbers, some statistics. And in this case, we're going to look at proportions. So our prompt tells us to identify those proportions. And the two ones that we're going to look at are the proportion of those who lived given that they were inoculated and versus given that they were, and it's really just going to be a repeat of this sentence, so we might as well just copy and paste. Given that they were not inoculated. And so note this phrase, note the given that phrase in both of them. So we want to know what the chances of living were, but under the different conditions that you were inoculated or not. So what we care about is comparing within these two columns. So within each column is going to have its own statistic. So the proportion of those who lived given that they were inoculated, that's going to be 238 out of 244. And the proportion of those who lived given that they were not inoculated, is going to be 5,136 out of 5,980. So we have two distinct totals here. And let's just make sure we got tracked what these numbers were. These were all the people who were inoculated and lived. And we want to compare that to all the people who were inoculated. So actually we should go ahead and calculate that. 238 divided by 244. 238 divided by 244. 0.9754. Versus 5,136 over 5,980. 5136 divided by 5980. 8589. 8589. And we've been writing these as percents, so it's fine if you'd like to do that. And what we can see here is the chance of living was higher if you had been inoculated than if you had not been inoculated. And so these are the two numbers that you really want to compare. They're both living rates based on your two groups. And notice how we didn't compare within the group that was lived, that did live, what percent of them had been inoculated. Because what we really care is about comparing the two groups, inoculated versus not inoculated. So what do we conclude about the relationship between being inoculated and the risk of death during a smallpox outbreak? Well, it seems like inoculation increases your chances of living. But it goes on to ask, why might you second guess your conclusion? But there weren't that many people who were inoculated. And we don't have any other information about them. Don't know much else. We only collected the minimum information about the participants in the study. It could have been the case that all the people who were inoculated were already very healthy. It could be that just by chance that the people who were inoculated were more likely to live. And we just don't know that for certain. And it's a major goal of statistics to piece out what happens by chance and what is happening by a cause and effect. So in the remainder of the videos about intro to statistics, this will be an underlying theme. See you there.